Hello guys, can you hear me? Hello, can you hear me guys? Okay. So guys, screen visible to you? Screen visible to you? Let's see here. So this is KNearest Neighbors. So here you are having different types of images. Suppose we have an image of creature that look either it is a cat or dog. We have to identify either it is a cat or dog. So for this identification, we can use KNearest Yeah, okay, sorry, there is a lot of net issue today, power issue today. Now, is it audible to you? Please respond. Is it audible to you? Guys, please it audible. Guys, is it audible? Please respond.
Yes, ma'am.
Okay, right. Okay then. So we'll see again an example afterwards. The next topic is case-based reasoning. So here, as we have seen the previous methods, that is KNN, that is called as lazy learning method. Locally weighted regression is also called as lazy learning method. Why? Because whatever the data which we give to the system, that data is stored as it is to the system, that will not execute anything. It stores the data into the memory and it keeps it till the end until it gets the new data. Okay, so once the new data is given to the system, the existing data will be compared with the new data. If any similarity is there in between existing data and the new data, the particular new data is classified to that similar existing data. So this is in KNearest Neighbors. Okay. So now, in case of case-based reasoning, so what it will do? So, in order to perform some reasoning task, in order to find out some solution to the current problem, so what it will do? It will take the previous existing method which is there previously. It searches for the old one. In case of case-based reasoning, if there is any solution which is existing previously, that will be compared with the new one. And with that, if it suits to the new data, then it will be adjusted to that new data and gives us the output. So this is in case of case-based reasoning. Okay. So here so if you see here in case-based reasoning, it has been applied to problems such as, so where this particular method has been applied. Okay, so case-based has been applied to case-based has been applied to problems such as, so what are the different problems? Conceptual design of mechanical devices based on stored library of previous designs. Say you have to design a pen or some laptop or some vehicle. Okay, so what you will do? You will be searching the data which is related to this, which is stored previously in the library. Okay, if there is any previous designs to this particular problem, so you will be searching the data. Okay, so what you will do, you will design the concept. Okay. So in case based reasoning, what will happen if there is any data or any solution which is stored in the library that will be compared with the new one. Okay. If you see one more example in court cases, okay, any legal cases which are there, which are similar to the previous one. What are the previous rulings to any particular case now which we are handling? Okay, so the lawyers will be searching for that. So this is one more example. And one more is solution planning and scheduling problems by reusing and combining portions of previous solutions to similar problems. So one more thing that is sometimes old solutions cannot be used as it is as to the new problems. So in that part, only a particular part of the solution can be used. ప్రీవియస్గా ఉన్న సొల్యూషన్లో మొత్తం సూట్ అవ్వదు, కొంచెం పార్ట్ మాత్రం సూట్ అవుతుంది, ఆ పార్ట్ని మనం తీసుకుంటాం. ఇంకో ప్రాబ్లం నుంచి వెళ్ళి ఒకవేళ కొంచెం పార్ట్ సూట్ అయిందంటే ఆ పార్ట్ తీసుకుంటాం. ఇవన్నిటిని కంబైన్ చేసి మన న్యూ దానికి అప్లై చేసుకుంటాం. మన న్యూ దానికి ఏమైనా సూట్ అయితే తీసుకొని అప్లై చేసుకుంటాం. సో దిస్ ఇస్ వన్ మోర్ థింగ్. దిస్ ఇస్ డన్ ఇన్ కేస్ బేస్డ్ రీజనింగ్. Okay. So there is one example which is related to cadet. What is cadet? That is case-based design tool. Case-based design tool system employs case-based reasoning to assist in the conceptual design of simple mechanical devices such as water faucets. Faucets ante taps. Okay. So ఇక్కడ water taps example తీసుకున్నాం. So what is that example? Just see here. It uses a library containing approximately 75 previous designs and design fragments to suggest conceptual designs to meet the specifications of new design problem. ఇక్కడ మేము ఏం చేస్తున్నాము, if you take one company is there, company called as Jaguar. Okay, so now this want to design a new tap, and they describe this in, this is input flow, then this should be output flow. If this is input temperature of particular water, and this has to be output temperature, itla describe చేస్తుంది problem ni. Okay, now according to this we have to design the tap. Okay, so for this requirement there might be already design which is developed in library. Okay, so now what you do, you take that particular design or conceptual design and try to refine it, and that matches your current design or problem. Okay, so this is the problem specification which has been given here in case of case-based reasoning. So this example has been explained. మీరందరూ యూజ్ చేస్తూనే ఉంటారు bathrooms లో two-way taps means one side if you open cold water, one side you can open hot water, so both at a time. So likewise, okay, so this problem has been explained here in case-based reasoning. Okay, so each instance stored in memory water pipe is represented by describing both its structure and its qualitative function. సో దాని స్ట్రక్చర్ దాని క్వాలిటీ రెండింటిని ఎక్స్ప్లెయిన్ చేసినారు ఇక్కడ. మనం మెమొరీలో ఎట్లా స్టోర్ చేస్తున్నాం ఆ పర్టికులర్ డేటా అంతా. ఓకే, న్యూ డిజైన్ ప్రాబ్లమ్స్ ఆర్ దెన్ ప్రెసెంటెడ్ బై స్పెసిఫైయింగ్ ద డిజైర్డ్ ఫంక్షన్ అండ్ రిక్వెస్టింగ్ ద కరస్పాండింగ్ స్ట్రక్చర్. మనము ఇదంతా డేటా స్టోర్ అయిపోయింది ప్రీవియస్ గా, మనం ఆల్రెడీ యూజ్ చేసింది. ఒకవేళ కొత్త ప్రాబ్లం ఏదైనా ఇచ్చినాం అనుకుని అది పాతదానికి ఎట్లా సూట్ అవుతుంది. సో దట్ ఈస్ ఎక్స్ప్లెయిన్ హియర్. You can see here there is one figure on the screen. So this problem setting is illustrated, whatever the problem which I have told you, that is illustrated in the form of figure. Okay, so on the left hand side you can see structure, on the right hand side you can see function. So this is structure and this is, sorry, so this is structure and this is function. Okay, this is function. Okay, so now they have taken T junction pipe, T junction pipe. T junction pipe అంటే ఏంటి అని అంటే, so T junction pipe. So now mouse is not working correctly. Just a moment. So if you see here, this is your T junction pipe. Okay. So this is your T junction pipe. These two are inlets. This is your outlet. ఇదేంటంటే వేడి నీళ్ళు, ఇది చల్లటి నీళ్ళు. రెండింటిని చెప్తే మీకు అవుట్పుట్ వచ్చింది. ఓకే. Okay. So likewise, you are using T junction 5. Okay. Now if you see here in structure, so this is your first inlet Q1. Okay. On the bottom you can see that is second inlet. So this is your first inlet and this is your second inlet. Okay. ఇవి వేడి నీళ్ళు, ఇవి చల్లటి నీళ్ళు. సో రెండు కలిపితే మీకు Q3 నార్మల్ వాటర్ వస్తుంది. ఓకే. సో Q1, Q and T are nothing but Q is your water flow, T is your temperature. సో మీ గీజర్లో ఎట్లా సెట్ చేస్తారంటే టెంపరేచర్ వాటర్ ఫ్లోకి తగ్గట్టుగా టెంపరేచర్ సెట్ చేసి మీకు వాటర్ ఫ్లో ఎట్లా రావాలి, టెంపరేచర్ ఎంత ఉండాలి, సో దాన్ని సెట్ చేసుకొని ఇస్తారు అన్నట్టు, అట్లా తయారు చేస్తారు అన్నట్టు. ఓకే. సో దట్ ఈస్ ఇన్ స్ట్రక్చర్. ఇఫ్ యూ సీ ఇన్ ఫంక్షన్ Q1 and Q2, these two are increase in water flow. Q1 and Q2 are increase in water flow. Then it should result Q3. అట్లాగే T1 and T2 both are increase in temperature. It gives us T3, temperature 3. అంటే మీకు T3 ఇస్తుంది. T1, T2 కలిపితే T3 ఇస్తుంది. Okay, so this is your function. Itla function. So this is my problem. The function should be in this way. So in this way, what we are doing, we are performing the function on my particular problem. Okay. Now the problem specification. Water faucet, my water tap. So while designing my water tap, what is the structure? When this functionality is required, so that I have to specify here. Okay. So this is my old design. Now what I'm doing here, I want new structure. To this new structure, I'm having some functions here. Specifications, there's some functionality is there. So what is that? Okay. So if you see here, CT and CF. T is nothing but temperature. F is your water flow. Okay. So it should result QC ante cold, QH ante hot. Temperature cold, temperature hot. Okay. So here CT represents your temperature, CF represents your flow of water. So when temperature and the flow of water is given, water flow should be QC. If temperature and flow is given, sometimes the water flow should be high. Sometimes it is cold, sometimes it is hot. Okay, it should be cold sometimes and it should be hot sometimes. So this is my functionality. So what I'm doing, this type of scenario I am designing. So what is the structure for this? Okay, so here QC and QT results QC, QH results QM, TC and TH results TM. కోల్డ్ హాట్ రెండు కలిపితే మీడియం వస్తుంది, కోల్డ్ హాట్ కలిపితే మీడియం వస్తుంది. ఓకే. So for this, the system refers to the library. So ఇది నా functionality. సో ఇట్లాంటి దానికి previous గా ఏదైనా డిజైన్ చేసి ఉందా? So what the my system is doing? My system is referring to the previous library. Okay. So for this particular system, it refers to the library, and which structure is used. It will try to retrieve it. Okay. So here you can see. So the top half of the figure shows the description of a typical stored case called T-junction pipe. So this is T-junction pipe. Till now what I have explained. Its function is represented in terms of the qualitative relationships among the water flow levels and temperatures at its inputs and outputs. Okay. So it is given inputs and outputs. So these are inputs and we are getting the outputs here. In the functional description, at its right, an arrow with a plus label. So here you can see plus label is there. So these are different plus labels. Indicates that the variable at the arrow head increases with the variable at its tail. If it is giving some input, it gives us some output. Okay. So for example, the output water flow Q3 increases with increasing input water flow Q1. Q1 increase ఉంటే Q3 కూడా increase అవుతుంది. Q2 increase ఉంటే Q3 కూడా increase అవుతుంది. So according to the water flow, it will increase. The output will be increased. According to the temperature, the output temperature will be increased. Okay. Similarly, A minus label indicates that the variable at the head decreases with the variable at the tail. If we decrease it on the output side also, it will decrease. So the bottom of half of this figure depicts a new design. So till now what I have told you, so this is your new design. For this we have to frame one structure. Okay. So the particular function describes the required behavior of one type of water faucet. ఒక ట్యాబ్ ది functionality అన్నమాట. So here QC refers to the flow of cold water. You can see QC refers to the flow of water into tap, QH to the input flow of hot water, and QM to the single mixed flow of water of the tap. QM అనేది మన అవుట్పుట్, QC QH అనేది మన ఇన్పుట్స్. సిమిలర్లీ టెంపరేచర్ కూడా అంతే. Q ఏమో మన వాటర్ ఫ్లో, T అనేది టెంపరేచర్. సో TC TH అనేది కోల్డ్ వాటర్, టెంపరేచర్ కోల్డ్, టెంపరేచర్ హాట్. దాన్ని బేస్ చేసుకొని TM మనకి output వస్తుంది. So it refers to the temperatures of the cold water, hot water, and mixed water respectively, that is TM. So we'll be getting TM. The variable CT denotes the control signal for the temperature that is input to the faucet, and the CF denotes the control signal for water flow. So given this functional specification for the new design problem, cadet searches its library. So what the cadet library will do, it searches for my new problem, whether any requirement which is related to the old one is there or not. Okay. Library for stored cases whose functional descriptions matches the design problem. If an exact match is found, indicating that some stored case implements exactly the desired function, then this case can be written as a suggested solution to the design problem. So if anything is matched with the previous one, so what will happen? It will be retrieved to the new one. If no exact match occurs, cadet may find cases that match various subgraphs of the desired functional specification. So what will it will do in cadet? If any data is not matched to the new one, okay. So what the cadet will do, if any similarity, some similarity is there in the previous one or not, okay. So if any
Similarity is there. That will be collected from that. Some similarity is collected. Some similarities collected from something, some problem. Some similarities collected from some problem. Some similarities collected from some problem. So these all will be combined to form new one. Okay. So that matches various subgraphs of the desired functional specification. So this new will be matched with the previous different specifications which are there in the library. Then that will be retrieved. So cadet searches for subgraph isomorphisms between the two function graphs so that parts of a case can be found to match parts of the design specification. So what is isomorphism? Isomorphism is nothing but the graph that have similar connections. The graphs which are similar connections that will be retrieved. అంటే మనకి ప్రాబ్లమ్ కి సంబంధించింది ఏదైనా డేటా ఉంటే దాన్ని రిట్రీవ్ చేస్తుంది. ఓకే సో cadet will search for that and it will be retrieved. So it uses a rewrite rule that allows it to rewrite the influence. So this is the rule which we will be using as that will be retrieved as rewritten as in this way. So this rewrite rule can be interpreted as stating that if B must increase with A, then it is sufficient to find some other quantity X such that B increases with X and A increases with A. So as I have told you, QC increase అవుతే QT కూడా ఇంక్రీజ్ అవుతుంది, TC ఇంక్రీజ్ అవుతే TM కూడా ఇంక్రీజ్ అవుతుంది. సో అట్లా. So this is a formula which we will be using in case-based reasoning. Okay. So this is about your third unit. So any doubts regarding anything, guys? So this is one example for KNearest Neighbors, as I have told you. So you see here, suppose we have an image of a creature that looks similar to cat and dog, but we want to know either it is cat or dog. So for this identification, we can use KNN algorithm and it works on a similarity measure. So we will be using KNN for similarity measure. Our KNN model will find the similar features of the new data set to the cats and dogs images, and based on the similarity features, it will put it in the either cat or dog category. So if you see here already, so here you can see, here in KNN classifier we have given some images. Cats, dogs images ఇచ్చిన సిస్టమ్ కి ఏమని చెప్పినాం, బ్లాక్ ఉండి 2 eyes, tail, long tail, okay, some features అది ఉంటే cat అని, white, brown, 2 ears, 2 eyes, somewhat small tail ఉంటే అది dog అని. So we have classified our data to our system. So now what we have done, we have given one new input value. Okay, cat image ఇస్తున్నాం, అది system కి తెలియదు cat అని. So what it will do, it will find its similarity with the already data which is existing in the system. Okay, and it will find the nearest value to the new input value, and it will be predicted as cat. Okay. So here you can see how does KNN work. Select the number k of the neighbors, calculate the Euclidean distance of k number of neighbors, take the k nearest neighbors as per the Euclidean distance. Among these k neighbors, count the number of data points in each category. Now assign the new data points to that category. Our model is ready. So in this way, KNN works. Okay, here you can see blue dots are one category, green dots are one category. One new, what has happened, we have given the data to the system and it is stored and it is kept as it is. Okay. Now what we have did, we have given k is equal to 5. That is nothing but for the new data, we have to find the similarity of 5 data points. Okay. So we have to calculate the Euclidean distance between the data points, and the Euclidean distance is the distance between 2 points. Okay. So it will be calculated in this way. So this is 1 point, and A is 1 point, and B is 1 point. X1, Y1, X2, Y2 Euclidean distance is calculated by this particular formula. Okay. So it will check the similarity between different points. If the new point is belong to category B, then it is grouped to category B. Otherwise, it is classified to category A. So in this way, we'll be using KNN. So here you can see. So K is equal to 5 we have taken. So what are the 5 nearest values which we are here we are selecting 5 K nearest neighbors as 3 from the green and 2 from blue. So these are 5 nearest neighbors. By using Euclidean distance, you can know. By calculating the Euclidean distance, you can know which are the nearest neighbors to the new data. Okay. So from this, green is having the majority role. Green is playing the majority role. So the 'Let's give your attendance. We'll stop here. Give your attendance. Series 523. Can you hear me?
Yes, ma'am.
Series 5E2. 17 series 6.
Present, ma'am.
17 series 11.
Present, ma'am.
17 series 527. 17 series 545. 17 series 556.
Present, ma'am.
563.
Present, ma'am.
582. Manoj Reddy. 5C4.
Present, ma'am.
5C7.
Present, ma'am.
5D4.
Ma'am,
G0. చెప్పమ్మా.
ma'am, 16E2 present, ma'am. Mic is not working, it seems, ma'am.
16.
E2.
మొత్తం